All right, so just finished doing your homework. Getting ready for next week, next work. My next work is to work on your twin. And it's being printed right now. So here's page 1. There's your homework that I just spent a lot of time on. There's the trash can. All right, so the first question on your test, just to ruin your entire day, is about Jack and Jill. Jack is 11 years older than Jill. So what does that tell me? That Jill is Jack minus 11. Or if you really wanted to, you could say Jill plus 11 is Jack. It's really up to you, but I'll have the questions written out. I'll have the choices probably out there for you. I don't know. I may not. I may just make this one entirely multiple choice and not do it in 2 parts. I might just do that. I don't know. Anyways, so either Jill is Jack, take away 11, or you add 11 to Jill and you get Jack. It says in 3 years, Jack will be twice as old as Jill. So the first thing that has to happen is that both Jill and Jack have to age 3. I'm going to put the equality symbol there because even though right now they're not equal, the goal is equality. So if Jack's going to be twice as old as Jill, you could either take 1/2 of Jack plus 3, or what I like to do, you could double Jill plus 3. And that's what I'm going to use because it doesn't have fractions. So now it's substitution, and I wrote this out multiple ways for you. You could replace Jack with Jill plus 11, or you could replace Jill with Jack minus 11. I'll actually do this one a little bit different than I've done the last 2 times. I'm going to take Jill plus 11, and I'm going to put it right there because that's what Jack is. I'm also going to distribute as I move on to the next line. Twice Jill plus 3 is literally twice Jill plus 6. When I substitute in, I'd have Jill plus 11 plus 3, which is Jill plus 14. Subtract the 6. Sorry, let's get Jill's over here, and the 6 is over there. If I take a Jill away from twice Jill, I have a single Jill, and 14 minus 6 is 8. So Jill is 8, which means that if you add 11, Jack is 19. So there's Jack and Jill. 2 is the money problem. You have 43 coins made up from pennies, dimes, and quarters. So if you take the numbers of pennies and dimes and quarters and you add them together, you'll get 43. Total value is $4.27, and I will do that using pennies. It'll be 427 cents. Instead of dollars, think pennies. Otherwise, you have to have decimals and stuff. Dime is worth 10 cents, penny's worth a penny, quarter's worth 25 cents. Additionally, you have twice as many dimes as pennies. Twice as many dimes as pennies. So you just got to think for a second about which one you double. You're going to want equality. But if I have twice as many dimes as pennies, if I double the number of dimes, which is what you want to do, it wouldn't make sense. I want to double the number of pennies because I want equality, right? That's what it's about. Now, this thing right here is going to have to be manipulated. Look at our form, PDQ constant, PDQ constant. We need to shift this over, 2p minus d plus no quarters, because we need what's called a placeholder, is 0. Fair warning, I'm probably not going to pick out equations for you next time. I've done that on the last 2, it feels like. So fair warning on this, you're going to have to write your own equations. Okay? It's going to be all you. From here, you can use TI-4. I'm not going to ask you to do a 3 by 3. I'm not going to ask you to do a system of 3 equations by hand on a test day. You're too slow for that. So second matrix math edit. It's a 3 by 4, 1, 1, 1, 43, 1, 10, 25, 427, and then 2, negative 1, 0, 0. Quit out, second matrix math. Want reduced row echelon form. Its input is matrix A. And there's what you get. Remember, this was pennies, dimes, quarters. So your resulting matrix here was 1, 0, 0, 12, 0, 1, 0, 24, 0, 0, 1, 7. Anyways, there's 12 pennies, there's 24 dimes, and there's 7 quarters. Makes sense too. So twice as many dimes as pennies. If you run the math on that, that'll give you $4.27. Those are probably the 2 hardest problems on the quiz. So we'll get them out of the way in the beginning. 3, find the zeros of the function below. It says replace y or f of x with 0. Give your solutions as ordered pairs. Okay? And what we are doing here is we're literally letting y be 0. That's how you find 0. You let y be 0. You find x-intercepts. So this thing factors. It's actually an a squared minus a b squared pattern. Is it? It's not an a squared minus b squared pattern. Almost got me on that one. You can pull a 256 from both terms, then you'll have x squared minus 2. That'll make it easier. If x squared minus 2 is 0, because we're using the cover-up rule, we don't even care about 256. We add 2, and then we counteract squaring by square rooting. We get that x is plus or minus the root of 2. So my ordered pairs here is that I have a root of 2 when y was 0, and I also have that x is a negative root of 2 when y is 0. Moving on to 4, that y becomes a 0. I shift the 100 over. 5 times x minus 4 squared is 100. I divide by 5. X minus 4 squared is 25. I counteract squaring by square rooting. The square root of x minus 4 squared is x minus 4. The square root of 25 would be plus or minus 5. I add 4 to each side. I have 4 plus 5, or x is 4 minus 5. I get that x is 9, or I get that x is negative 1. So my ordered pair here would be 9, 0, and negative 1, 0. Factor. So this one moves straight into factor. It's not even about zeros, it's about factoring. I'm going to guess I picked on 4n and 3n. I am too tired to do anything in my head right now. So I'm just going to guess that I picked 4n and 3n. And I'm going to guess that I picked 3 and 5. I was right. That's 9n, and that's 20n. I was wrong, wasn't I? No, I wasn't. I was right, because 20 minus 9 is 11. So I need to be a positive 20, but a negative 9. That's how she factors. Find the complex solutions using the quadratic formula. So the quadratic formula goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. Plug stuff in. It's already in standard form. Just plug your stuff in. A is 6, B is 8, and C is 7. This is actually, when you're supposed to use the quadratic formulas for complex or things that have square roots in them that you just can't do by factoring easily. So let's plug some crap into this thing. X is opposite B, which is negative 8 plus or minus square root of an 8 squared minus 4 times A, which is 6, times C, which is 7. All sitting pretty over twice a 6. What's inside the radical? Whatever 8 squared minus 4 times 6 times 7 is. negative 104. Sitting over 12, because 2 times 6 is 12. I'm going to go ahead and do some breaking apart here. I'll have negative 8 over 12 plus or minus. The root of 104 is imaginary, and 104 is divisible by 4, and the root of 4 is 2, so 2I root 26, sitting over 12. Then I can do my reduction. Negative 8 over 12 is going to reduce down to negative 2/3, plus or minus 2I root 2I over 12 is I over 6. So I root 26 over 6. Man, I'm burning up today. Simplification says show your work. I don't understand why you won't show your work. You just want to do it in your head. Actually, you just want to use photo math. That's what you want to do. It's cool. Keep on failing. So this is 2 over 3 plus the root of 5. To simplify this, you multiply the numerator and denominator by the conjugate of 3 plus root of 5, and the conjugate of 3 plus root of 5 is obviously 3 minus root 5. You'll distribute up top. 2 times 3 is 6. 2 times the negative root 5 is negative 2 root 5. Down low, all you got to do is F and L. 3 times 3 is 9. Positive root 5 times a negative root 5 is minus 5. Moving on with my life. 6 minus 2 root 5 over a 4. I'm going to split that into two parts so you guys can see the simplification better. That's 6/4. Take away 2 root 5 over 4. That's got another reduction coming. 6 over 4 is 3/2. 2 over 4 is a half, so minus root 5 over 2. Which you could just write as 3 minus root 5 over 2. You could have. And you will very likely see things like that. That's actually pretty common with radicals to leave them like that. Simplify the complex number. Oh, Jesus would foil this thing. 2 times 3 is 6. 2 times 7i is plus 14i, if I can write. Negative 4i times 3 is minus 12i. Sorry, I'm a lefty. Negative 4i times 7i is negative 28 squared. Say negative 28i squared. And the way I was telling y'all to do these was to cross out the I squared with a better working pen and make it positive. That's just what you do. So then you can add your like terms. Your like terms are 6 and 28. You put them together, you get 34, and then you got 14i minus 12. That's plus 2i, and you're done. Then you got this one underneath it. 21i to the 18th minus 5i to the 13th power. And the deal on these was to take the exponent, divide it by 4, and keep the remainder. So I'm going to take 18, I'm going to divide it by 4. That is 4 times the remainder of 2. So the leading piece becomes 2i squared. Okay? Take I to the 13th, take a 13, divide it by 4. That happens 3 times the remainder of 1. And the secondary piece just becomes minus 5i. Now, I ran across an I squared. I mark it out, I change the sign. This is negative 2 minus 5i when everything's said and done. Number 10 is something I didn't teach in class. I shouldn't have to teach it. Will you miss it? I'm sure some of you idiots will. I shouldn't say that on recordings. I'm sure some of you very smart young individuals will get this wrong. Don't. 3 minus 4i, distribute the negative, minus 7 plus 3i. That's the first step, distribute the negative. A lot of kids won't do it. You won't do it. I don't know why you won't do it, but you won't. Focus on likes. 3 minus 7 is negative 4. Negative 4i plus 3i is minus I. It's that hard. Page 1. Done. Page 2. That is a legit question on your test. There's no need to worry about distribution. You just add like terms, it's a plus symbol. That's 9 plus, oops, I about screwed up. Here I am talking smack about y'all. 9 minus 3i. And I'm sure I made a mistake in here. Probably made a mistake on the one I was talking smack about. Clean this bad boy up by using the conjugate of 4 minus 4i, which happens to be 4 plus 4i. And this will take some time. I hate it for you, but it will. It's the numerator that's the pain in the butt, because you got to do the full FOIL process up top. We'll get 4 times 4, which is 16, 4 times 4i, which is 16i, negative 3i times 4 minus 12i, negative 3i times 4i minus 12i squared. Down low, you do first and you do last. 4 times 4 being 16, negative 4i times positive 4i is minus 16i squared. So the I squareds came into being again, and the deal on those again is, for what, the third time? Cross them out, change a sign. Cross them out, change a sign. Done. Now we can combine like terms. 16 and 12 makes 28. 16i minus 12i is plus 4i. Down low, 16 and 16 makes 32, and you know full well that Milbrath-Math never gave you an answer that looks like that, because you know full well you didn't figure out how to get that answer because you cheated. Reduce the fraction, or actually break it apart, 28 32nds plus 4i 32nds, and then simplify the fractions. You cheated because you couldn't even do the simplification. That's why you cheated. Anyways, 28 and 32 are both divisible by 4. That's going to be 7/8. 4i and 32 are both divisible by 4. That's I over 8, which is fine. If you don't like I over 8 the way it looks, you can write an eighth of I. It doesn't really matter how you write it. I don't care. They're the same blasted thing. Moving on to 13. Oh, it's a 2-column proof. Statements and reasons. So the first statement is whatever is given. X squared plus 4x minus 4 equals 0 because it's given. And I've got all the choices down here. Given is choice 2. That is choice 8. The next step in completing the square is to move C to the right-hand side. Actually, the next step is actually to divide by A, but A is 1, so I'm sure it says that somewhere in here. It's actually statement number 12, move C to the right-hand side. X squared plus 4x is now 4. Moving on to 5 here. What I would do from here is I would take half of B. B is 4, by the way. I'd cut it in half. I'd get 2. I'd square it and I'd get 4, and I'd add it to both sides. So I'd have x squared plus 4x plus 4 is 8, which is choice V. And what I did is I took half of B, I squared it, and I added it to both sides, which was statement xi. This will now factor as x plus 2 all squared. That's how it factors. That's how I taught it. Still equal to 8. That's choice X. And what happened is the left-hand side, which is choice 4, was factored perfectly. I would then counteract squaring by square rootings, and I'd have x plus 2 equals plus or minus 2 root 2, because root 8